Hello, in this video we're going to be doing a couple examples of integration by completing the square. So you want to try completing the square when the denominator of your problem is not factorable. If it is factorable, then you probably want to do integration by partial fraction decomposition. So let's do this first example. Couple side things. First thing is we're generally going to have quadratic trinomials like this, and this is our format that we usually talk about. To complete the square, we're going to use b over 2 squared, so that's something that we want to have memorized. So let's get into this problem. Again, the denominator is not factorable. A perfect square trinomial is what we want, and that's what completing the square accomplishes for us. A perfect square trinomial is a trinomial that can be factored, so it's the same thing twice, so you have something squared. So what we have up here is not a perfect square trinomial, so first thing we're going to do is I want to get a perfect square trinomial, so I'm going to put a blank, and then I have the 7. To complete the square, like I said, we're going to do b over 2 squared. Our b here is -4, so -4 over 2 squared, that's -2 squared, which is 4. So if I add 4, I now am going to have a perfect square trinomial. But I can't just add 4 to a problem, that just changes the integral. So if I add 4 somewhere, I also need to subtract 4 somewhere else. So I'm going to add 4 and subtract 4, and that way I'm only adding 0, which doesn't change my problem. At this step, we want to factor our perfect square trinomial, so that's going to be x minus 2 squared. And then 7 minus 4 is 3. Now for all of these, we're going to be converting them so that we use our inverse trig identities with integration. So I'm just going to tell you for this first one, we are using this identity. So we're going to be using inverse tangent. So first step for all of these is you are going to look at, I have a 1 here in my identity, but I have a 3 in the problem. So we want to fix that first. So I'm going to factor out a 3 in the denominator. I'm going to have x minus 2 squared over 3 plus 1. Second thing that we're going to tackle is this is an expression squared in my identity. Right now in my problem, I have an expression squared divided by 3. So I want to rewrite it. I'm also going to bring my 1/3 out front. So I'm going to rewrite this as x minus 2 over the square root of 3 squared plus 1 dx. Now notice that we're looking pretty similar to our identity. We're going to do u substitution. Usually you're going to take your stuff that's squared, that expression, and you're going to make that your u. Keep in mind that this is x over rad 3 minus 2 over the square root of 3. That means that our du is going to be 1 over the square root of 3 dx. Now I have a dx, but I don't have 1 over the square root of 3, so I'm going to put that in there. If I multiply by 1 over the square root of 3, that means I need to multiply by the square root of 3 somewhere else, so that I'm multiplying my problem by 1. Okay, next, out front now I have the square root of 3 over 3, and then I'm going to rewrite my problem to be in terms of u. And notice now we have our identity exactly. So I can write this out. I'm going to do it over here. We have arctangent. I'm going to plug my u back in. And then don't forget your plus c. And that is your answer. Let's do another problem. Okay, for this second problem, I also want to point out at the top, the b over 2 squared only works if your a is +1. So I want you to notice for number 2, your a is -1. So we are going to have to deal with that. First up, I'm going to switch those two terms around. I think it's going to make more sense to us. And then I'm going to factor out a negative. Okay, new line. Next, I'm going to complete the square. Your b here is -3, so b over 2 squared is going to be -3 over 2 squared, which is 9/4. Now, I want you to notice if I were to distribute that negative back, I would have -9/4. So I'm not adding 9/4 to the problem, I'm subtracting 9/4 because of distributing that negative. So since I'm subtracting 9/4, I want to also add 9/4 to make sure I'm adding 0 to the problem. Next up, we're going to factor our perfect square trinomial. And I should have completed this. So I have -x minus 3/2 squared plus 9/4 dx. And for this one, I'm just going to tell you the identity that we're using is for arcsine. So this is so this is the identity that we are aiming for. Okay, so next thing I'm going to do is I'm going to switch the two terms under the radical, just because in the identity the squared term is second. So I'm going to make this okay, now same thing as the previous problem. First thing I want to do, I have a 1 in the identity, but I have a 9/4 in the problem. So I'm going to factor out the 9/4. I have x minus 3/2 squared over 9/4. Second thing is I want to make sure that I have an expression squared for this second term. And then I'm also going to take the square root of my 9/4, that's 3/2. I'm going to make this x minus 3/2 over 3/2 squared dx. All right, okay, at this step, I'm ready to do my u sub. We're going to make u equal to my expression that's squared. But let's make this a little bit nicer. Dividing by 3/2 is the same thing as multiplying by 2/3. Distribute the 2/3, and we get u is 2/3 x minus 1. That means that du is 2/3 dx. So I want you to notice I have 1 over 3/2. That's the same thing as 2/3. So I'm going to rewrite this one more time. 1 over 3/2 is the same thing as 2/3 over what we had before. So I have my du already in the problem. So I'm going to rewrite to be in terms of u. I'm going to have 1 over rad 1 minus u squared du. Notice that this is your identity. So I have arcsine of u. I'm going to replace with this u plus c. And that is your final answer. So those are a couple of examples of integrating using completing the square. Thank you for watching.